Good morning, all of you. Welcome to the class. In the previous class, we have discussed graphic system. What we have studied? We have studied concept of graphics, types of graphics, and concept of display device, and we have discussed CRT, working principle CRT, how CRT is operated. Okay. In today's class, we studied another display device, raster scan display. Okay. So, in this class, we have covered concept of raster scan display, working principle of raster scan, applications, and advantages and disadvantages of raster scan display. So, let us display what is raster scan. Okay, raster. Raster means a rectangular array of points or dots. An image is subdivided into a sequence, usually horizontal, strips known as scan lines, which can be further divided into discrete pixels for processing in a computer system. A raster image is a collection of dots called pixel. These things also we have discussed in the previous class. What is pixel? Okay. Here is a figure. It shows the number of pixels. Horizontally, it shows a number of pixels. Okay. Or in a rectangular object, an array of points or dots known as pixels. Okay. This is the example of raster image. We also covered this in raster graphics. Okay. Here is a picture. This is the original picture. When we enlarge this picture, it will look like this. Only small tiny pixels. Okay. Or square boxes. In raster scan display, the CRTs are display look like this. Here, this is your phosphorus coated screen. Okay, this is your connectors. This one is the connectors. This is the electron gun, or this is the control electrode. This is the focusing electrode. Okay, this is the horizontal deflex plate. This is the vertical deflex plate. This is the electron beam. And here another things are also there. Scan line, horizontal retrace, vertical retrace. Okay. And this whole is the phosphorus coated screen. The horizontal retrace, vertical retrace and scan line we have discussed in this class. Okay. Let us come to the point architecture of raster scan display. In the raster scan display, it consists display controller, CPU, video controller and refresh buffer, which is your memory buffer. Okay, keyboard, mouse and last one is CRT. These things are consist in the architecture. How all these things are operated, we will discuss. Let us come Working principle of raster scan display. Okay. The display image is stored in the form of ones and zeros in the refresh buffer. When we store an image in a computer, it will store in its image form or in what form? It is only stored in a binary form because computer will understand the binary. Okay. So the display image is stored in the form of 1 and 0 in refresh buffer. The video controller reads this refresh buffer and produce the actual image on screen. The role of video controller is it reads the refresh buffer or it reads from the buffer the image which is stored, okay, and produce the actual image on the monitor or the screen. Okay, it will scan one line at a time from top to bottom and back to top. When we read the image from the refresh buffer, it will scan one line at a time. At a time it will scan one line from top to bottom and back to the top. In this method, the horizontal and vertical deflection signal are generated to move the beam all over the screen in a pattern shown in the next figure. We will show you in the next figure. Here, the horizontal and vertical deflection signals, horizontal, this is the horizontal, and vertical in this way. Okay, vertical signals are generated to move the beam over the screen in a pattern shown like in this figure. Okay, here beam is swept back and forth from the left to the right. This is your scan straight line. The straight line is known as the scan lines. The straight line or solid lines is the scan line. Okay, and the dotted line which is shown here, the dotted line is the horizontal refresh. This left to right, the dotted line which is left to right is right to left is the horizontal retrace, and the dotted line which is bottom to top, this one, okay, is vertical retrace. When the dotted line right to left, it is horizontal retrace, and the dotted line which is bottom to top is known as vertical retrace. Okay, and another one is here, the solid line means the beam is, it is on, and the dotted line means it is off. Solid line means it is on, dotted line means it is off. Okay. The beam is moved from left to right, which is shown in this figure. Okay. When beam is moved from the right to left, it is off because it shows a which type of line? Dotted line. That means it is off. And process of moving beam from right to left after completion of row is known as horizontal retrace. When beam is reached at the bottom of the screen, it is made off and rapidly retraced back to the top left to start again. And process of moving back to top is known as vertical retrace, which is shown in this figure. Okay, in that figure, the screen image is maintained by repeatedly scanning the same image. This process is known as refreshing screen. At a time, it will scan only one line. or repeatedly it will scan all the lines. Okay, this process is known as refreshing screen. Here in this figure we will also show that individually in the first monitor it is scan only one line. After that it repeatedly it will scan only second line, third line, fourth line, second line, third line, fourth line, fifth line. The here it retrace the only it can he shows a triangle. How to draw this triangle? The at a time he shows a one line, then another line, then third line, then fourth line. In this way only scan at a one line and retrace the figures. How it is look like this. After in the fourth stages it will complete the triangle. Okay. Next we come to the working. In this working principle we will also continue. In raster scan display, a special area of memory is dedicated to graphics only. Okay, which is shown in the architecture here. This is the frame buffer. Okay, which one is your what 011 form? Okay, the frame buffer holds a set of intensity value for all the screen points. The points which are shown in your screen. The screen points intensity values are stored in the frame buffer. That intensity value is retrieved from frame buffer and display on screen one row at a time. That means the screen collection of dots are in your screen, which is known as pixel. Okay, all these things are stored in your the dots are screen's points are also have a intensity value. These values are stored in a frame buffer. The intensity is retrieved from the frame buffer and display on the screen one row at a time. The first रो में कौन सा इंटेंसिटी वैल्यू है उसको वो वहाँ से रिट्राइव करता है और उसको स्क्रीन में दिखाता है. तो दैट मीन्स वो कहाँ से लाता है, स्टोर कहाँ पे हो रहा है, फ्रेम बफर में. कहाँ से रीड कर रहा है, फ्रेम बफर से रीड कर रहा है. एट ए टाइम वन लाइन वो उसको रीड कर रहा है. उसी वन लाइन में हुई इंटेंसिटी वैल्यू आर स्टोरेड वो उसको डिस्प्ले कर रहा है which he want to draw. Okay, each screen point referred to as pixel or pale. This is known as also picture element. Okay, each pixel can be specified by its row and column numbers. In each pixel can be specified by its row or column numbers. That means a pixel is which type, one square type circles. That means the square the pixels position is the row and column number, combination of row and column numbers. Okay, it can be simply black and white system or color system. In simple black and white system, each pixel is either on and off. So only one bit per pixel is needed. One and only on and off. On means 1, off means 0. Okay. Off means 0, on means 1. Additional bits are required when color and intensity variations can be displayed. Up to 24-bit pixels are included in high quality display system. In black and white system it is only either on and off. Only 1 bit pixel 1 bit per pixel is needed, either 1 and 0. In color monitor, additional bits are required. Okay. On a black and white system with 1 bit per pixel, the frame buffer is commonly called a bitmap. When we work in black and white system, 1 bit per pixel, the frame buffer is known as bitmap, and for the color system or additional monitor system with multiple bits per pixel, the frame buffer is called pixmap or pixel map. Okay. Next, we have discussed type of scanning. That means how the beam traveled in raster scan system. Beam can be traveled in two types. One is interlaced scanning, another one is non-interlaced scanning. Okay. What is interlaced scanning? In interlaced scanning, each horizontal line of the screen is traced from top to bottom, due to which fading of display of object may occur. This problem can be solved by non-interlaced scanning. That means here it will scan even and odd wise. Let us discuss how it is. Every full screen of information is made up of two separate fields. In the screen, suppose this Suppose this is your screen, monitor screen. Okay. The lines are like this. Okay. Continuously, every full screen information is made up of two separate fields. One is odd field and another one is even field. That means first line is the number 1. This is the number 2. This is the number 3. That means it can divide it even line and odd line. That means first scan all the odd fields, that means 1, then 3, then 5, like this. After that he can scan even field 2, 4, like this. Okay. So here is also write the odd lines are printed in the graphic screen and then even lines are printed in between the odd lines. At that time, after completion of odd lines, then he scan all the even lines and printed between the odd lines. Okay. Before odd lines are fade away. After few times odd lines are fed up in this interlacing system. Okay, scanning. So the after few seconds he can even scan the even line and place in between the odd fields. Okay. For interlaced display, refresh rate of is 60 frames per second. I show you a picture. Let all of you clear. Here it shows. Okay. Here this is the main figure, actual figure. How this figure is displayed in the screen. The horizon, the number of lines are continuously there in the screen, but in interlacing system it can divide it two parts or two types of field, odd field and even field. First it can scan all the odd lines. After scanning all the odd lines, the picture is look like this. Then after completion of scanning odd lines and print in the screen, he can immediately scans even line. Even lines are here. It also shows you 2, 4. When you zoom out, it will display, clearly display all of you. And the after completion of odd lines, it will immediately display the scan the even line and display in the display in between the odd lines. So here odd line and even line, when it combine, the picture is look like this. Okay, all of you understand clearly what is interlacing? I hope you all of you clear. Then we discuss what is non-interlacing scanning. All the disadvantages, which one is fade off immediately or some fluctuation are also there, all these things are cover up in non-interlacing. Okay, a non-interlacing scanning or progressive scanning does the whole jobs in one pass, tracing each row consecutively. In the interlacing scanning, it will scan odd line and even line separately, but in non-interlacing scanning, it will tracing each row consecutively. That means first one, suppose this is your monitor screen, first one line, second line, then second line, then third line, then fourth line, then fifth line. In this way it will scanning all the lines. Okay. In non-interlacing scanning or progress scan, the display video speed is quicker than interlaced scanning. Here the video quality is superior than interlaced scan and there is not present combining effect in progressive scan. In interlacing scanning, he scan even line odd line, so the picture is combined. But in interlacing scanning, it is consecutively scan all the rows, so here no combining effect is there. In interlaced scan, display refresh rate of is 30 frames per second, but it gives flicker. Here is a new word comes, flicker. What is flicker? Flicker means it change in light intensity. That means generally small fluctuations in voltage. And also it rarely harmful to electronic equipment and also causing for annoying or noticeable changes in lighting level. Okay. So these are the interlaced scanning and non-interlaced scanning. Here is a picture also shows interlaced versus progressive. In interlaced scanning, this is the odd line, and this is the even line. The even line are placed in between the odd line, then the picture will complete. Okay, but in non-interlaced scanning, it will consecutively scan all the lines. So this picture is look like this. Also fluctuations are there. Okay. Next we come to the point which important to discuss, what is resolution and what is aspect ratio. Resolution means it is used to describe the number of pixels that are used on display image. Resolution means the number of pixels in your screen or the number of pixels that are used in a image. That is known as resolution. Okay. Aspect ratio is what? Aspect ratio is the ratio of width to its height. It measures is unit in length or number of pixel. Also it is the ratio of the number of x pixel to the number of y pixel. X pixel, y pixel means suppose it is your screen. Okay. Here if we shows it a graph like this is the x axis, this is the y axis. This is the 0, it is x and this is the y. Okay. The ratio is number of pixel of x pixel and to the number of pixel. Suppose this here is one dot. Okay. That means we know that or we can find that the point or the dot or the pixel location is what? That means in the x axis the number is what? Or y axis the intersection point is that point. Okay. The standard aspect ratio of PC is 4:3. Some common resolution of respective number of pixel and standard aspect ratios are also given below. You also heard these things. 322 into 240 resolution means number of pixel is 76800. The aspect ratio is 4:3. If we constant the ratio 4:3 but resolution is we are getting the high resolution but aspect ratio is that. Okay, then the number of pixel is 640 into 480 resolution but here number of pixel is 307200. Aspect ratio is same. In this same aspect ratio also we can increase the resolution so that number of pixel also increases. Okay. Let us come to the point application where raster scan system is used. Realistic display of screen or realistic image will be displayed. Here is also raster scan displays used. Home television, computer, printer, all here is also is raster scan display used. Okay, some common raster images format we will also discussed in previous class in raster graphics: BMP, JPEG, GIF, PNG, PSD. That means Adobe Photoshop, Portable Network Graphics, Graphics Interchange Format, Joint Photographic Expert Group, Windows Bitmap, all these things. Okay. Then advantages. Computer, monitors and TV use this method. Which method? Raster scan method. Realistic image also use raster scan method. Different colors are to be generated in raster scan system. Shadow screens are also possible in raster scan method. Okay. High degree realism is achieved in picture, advanced shading and hidden surface techniques will possible in raster scan display. Okay, these are the advantages. Let us discuss what are the disadvantages. First disadvantage is resolution is low resolution. Okay, or it is also very expensive. Line produced are zigzag as plotted, values are discrete. Okay, but in random scan or vector scan method lines are smooth lines. So students, I hope you all of you clear about raster scan system. You will also go through it and read carefully. Okay, then you will clearly understand. So thank you.